Okay, so I'm starting another course. Well, it's gonna be based on a book. Not sure I can call it a course, but it'll be a set of podcasts like most of the other set of podcasts I've been posting. So this is called How Bad Are Bananas by Mike Berners-Lee, a prof in the UK. Basically, he focuses on the carbon footprint of everything. As he cautions, this is not to be taken as an advice on how to live your life or the accuracy of the exact numbers. There is many complicated issues in computing carbon footprints, but it gives you a sense of the relative scale of things. Eating a banana versus eating beef, or driving versus flying, or riding your bicycle, and so on. All for your awareness and not necessarily to give you advice on how to live your life. Okay, so let's start right away with these things that are under 10 grams. Okay, various things we'll consider, starting with a text message. So how much does a text message cost? A 0.014 gram of CO2 equivalent for one message, 32,000 tons of CO2 equivalent of all world's texts for a year. Of course, the number of texts are increasing, especially in developing countries where the number of cell phones are increasing. So the question is then, is that something to worry about? Of course, everything we do that affects carbon emission is something to worry about. And we have already, I have already mentioned CO2 equivalent in several other courses I've posted. But here, in case you don't know, CO2 has a certain global warming potential, which means for each outgoing long wave radiation it traps, there is a certain amount of excess energy that is not being allowed to go back to space, which means it warms the Earth's atmosphere, which is our main concern. Of course, some of that energy, 93% of that additional energy goes into the ocean, but the system retains energy. When we say CO2 equivalent, we look at other greenhouse gases like methane, nitrous oxide, and hydrofluorocarbons to see how their global warming potential compares to CO2 over a certain period of time, either for the same number of molecules or weight per kg or per molecule. There are differences in the way you do it, but that's CO2 equivalent very briefly. So our text messages are something to worry about in the big picture. Not necessarily when you look at the amount of tons emitted per year across the world, even if it goes up a little bit, and even if this number is off by a little bit, we can relax about worrying about text messages. Okay, a cup of water, 0.06 gram CO2 equivalent for one cup, 23 kilograms or 51 pounds of CO2 equivalent a year's tap water for a typical US citizen. Okay, this is just water that is being supplied to you and you are pulling out of the tap and doing whatever you do with it. So a year's supply for one person is the same as a 27-mile drive in an average passenger car. That includes drinking. So the other point to be made here is that we have to include drinking, washing, cleaning, and the lot in this. But what is not included is that wastewater treatment. Anything you do with the water and you let it run into the system, wastewater treatment actually is much more carbon intensive than the process of taking natural water and cleaning it and supplying it to you via tap water. So what does it mean? Basically that means reduce wasting water. That's a no regret decision. Of course we are domestic users are not always the biggest ones. Agriculture and industries take up a lot. Agriculture can often be the biggest user of water and so on. So for comparison, that's water. A web search zero point 0.2 grams of CO2 equivalent is the Google's estimate for the energy used at their end. So you go onto Google search window, you type a sentence, a word, a phrase, and you hit search, and it goes through its calculations. That's what Google estimates. 0.7 grams CO2 equivalent is from an efficient laptop, so it's a lower estimate than you could get in reality. 4.5 grams of CO2 equivalent from a power-hungry machine, and making higher estimates of power used in the network. So obviously it depends on where you are doing the Google search. So that is between 2 and 14 seconds worth of a 10-ton living for 30-second single search. Okay, of course, just the search is this, but then when you download something and you read it on your laptop, or you print it on a paper and read it and so on, there is additional emission happening. But overall, we can probably relax about it. According to this book, reading the stuff we find is an altogether more carbon hungry activity. Okay, walking through a door. I have written about this in Huffington Post India a few years ago, on how every time we enter the door and don't use the rotating door, or don't are not careful in closing the door after us, or even things like standing on escalators. This is something that always amazes me. You go into malls or airports or buildings, people get on the escalator and stand. Able-bodied young people and middle-aged people. This is a convenience, so you must be walking up. By standing, you are in fact increasing the energy use, right? So let me not rant, but walking through a door can be 0 CO2 equivalent for a normal household door on a summer's day. So this is talking about UK, could be very different for Indian households. 3 grams of CO2 equivalent getting in through your front door on a cold New York winter's day, because there is heating going on, and you open the door, you lose the heat, and you don't close it fast enough, you are heating the world for a second. So that's 3 grams. 84 grams CO2 equivalent if big electric doors are opening into a large stairwell on a cold windy day in New York. At the end, that's a banana's worth of greenhouse gas every time you enter the building. So we will keep banana as a baseline, since the title of the book is How Bad Are Bananas? It gives you a relative sense. Banana is healthy, all sports people want to eat it, locally grown, great. There are many issues with bananas that we will look at. How it's shipped, how it's stored, how it's ripened, and so on and so forth. So walking through a door can cost, depending on where you are and how careful you are with the way you deal with the door. Okay, waiting for an elevator, for example. Why not walk up a flight of stairs or 2 instead of waiting for an elevator? Okay, an email. 0.3 grams CO2 equivalent is cost of a spam email. Why is it smaller than a proper email? Because typically spam goes off into the spam folder by filters, and it's not even read, but people can go in and scan the spam folder to see if legitimate emails have gone into spam, and so on and so forth. Nonetheless, there is a lot of spam. There is some estimates by McAfee that a lot of, so I'll come to that in the next slide. So 4 grams of CO2 equivalent is what a proper email emits. 50 grams CO2 equivalent is an email with long and tiresome attachment that you have to read. So you can think of WhatsApp messages. SMS is cheaper than WhatsApp messages, Messenger messages, and so on, because the protocols used to send them are different energetically as well. Energy use wise. A typical year of incoming mails adds up to 135 kilograms, 300 pounds of CO2 equivalent, over 1% of the 10-ton lifestyle, and equivalent to driving 200 miles in an average car. So it's not small. If you add up all the emails going around the world, it adds up to tens of millions of cars driving around the whole year. So the 10-ton lifestyle is something that the author discusses. If everybody went to a 10-ton lifestyle. You can think of the richest people, the top 1% is emitting 90% of the carbon luxury consumption right now, the bottom 50%, the next 50%, and the remaining 40% are emitting less and less. So you can adjust the carbon footprints and bring everybody, let's say, to an average of 10 ton, and that could be one way to think about things. So, according to research by the spam and virus protection specialist McAfee, a remarkable 78% of those incoming emails are spam. Around 62 trillion spam messages are sent every year, requiring the use of 33 billion units of electricity and causing around 20 million tons of CO2 equivalent per year. Letter is 60 times more carbon intensive, but emails are many more. This is called the rebound effect, where something that is more efficient, let's say energy use wise, tends to be used much more because people feel like this is not costing much energy. Okay, and letter writing has dropped off anyways, but the paper, the shipping and everything is going to cost 60 times more than emails, just if you consider one letter versus one email. Taxing spam would reduce them potentially and also save carbon emissions by reducing the numbers, plus generate revenues that could be used for other things. Drying your hands, zero carbon CO2 equivalent if you just let them drip and dry by natural processes. 3 grams CO2 equivalent for Dyson Airblade, whose technology is not to heat the air but just blow it at a much faster speed, so the evaporation, which is proportional to the wind speed, dries much quicker with less energy. 10 grams CO2 equivalent for one paper towel if you are honest enough to use only one. Typically people tend to use more than one. 20 grams CO2 equivalent for a standard electric dryer, which heats the air and blows it at a lower speed. So on average, if you used public toilets 6 times per day, your hand drying would produce around 15 kilograms CO2 equivalent per year, equivalent to 1 kilogram of beef. So you keep these things in mind and do the proper calculations. I think I'll come back to a plastic carrier bag in the next podcast, because there are some nice additional points to be made there in terms of how we assume intuitively that paper is always better than plastic, or that a cloth bag is going to be better than plastic as well. Well, actually it turns out that it's not that simple. It depends on the various science questions you would ask of the use and the context of the use of these bags that we are talking about. So let's do that in the next podcast. So this is just going to be like this, discussing carbon footprints of various things, so you can just begin to be aware of the relative magnitudes of the things you are doing in a daily life and how they relate to carbon emissions, so that you can develop your own portfolio and try to manage your own carbon and not be harangued by anybody, especially climate scientists who are saying the world is coming to an end, often without changing their lifestyle much. Okay, so anyway, I don't want to criticize anybody, but you know what I'm saying.